So earlier we talked about the order of which things being run was something you had little or no control over. However, you do have control over the order in which results are presented. And there's a couple of different ways that that can occur. So one thing you can do is you can control if or how results are presented in so-called encounter order. So let's talk about this. So we talked before about the fact that the apply phase is non-deterministic largely, but the results part can be more deterministic. So this is something you can in fact control. And you can control the order if you want the results to be presented in encounter order. Now what the heck is encounter order? So encounter order, or EO, is simply the order in which the stream source, like an array or a linked list or a set or whatever, makes its elements available. And it turns out that certain kinds of data structures, certain kinds of collections have an encounter order and other ones don't. So for example, lists have an encounter order. The 0th location, the 1st location, the 2nd location, and so on. That's the order in which the elements are encountered. For various reasons, sets do not have an encounter order because there's really no, especially a hash set, there's really no rhyme nor reason to how the set is organized internally. It's just hashing the values, so it doesn't matter. So a hash set doesn't have an encounter order. That's a flag that's not set in the splitterator attributes or characteristics. So here's the rules. Encounter order is maintained if the source is ordered, like you have a list, and the aggregate operations that are used are obliged to maintain that order. Some aggregate operations maintain encounter order, some are not. So if they are, then it'll maintain it. And what's interesting about this, and this is important to understand from the point of view of performance, the semantics of this rule about maintaining if the source is ordered and the aggregate operations are obliged to maintain order is true whether or not the stream is parallel or sequential. Now, why that's important is because if you use a parallel stream and you want encounter order preserved, that may actually add additional overhead to the way in which the parallel streams framework combines the results, because it has to combine them in order, in the encounter order. Whereas if you don't care about the encounter order, it can provide an opportunity for the streams framework to optimize the performance. And we'll take a look at how that works later. So the performance may differ, but the semantics are the same. So as a general rule, which doesn't always matter, preserving encounter order is a bit more expensive than not preserving encounter order, because by the time you get down to the terminal operations, if encounter order must be preserved, it has to rearrange everything so you get the results in the order that you encountered them initially, which may not be anything like the order in which they actually ran in the underlying apply phase. So that's just a quick overview of ordering of results. Now we're going to take a look at some examples here shortly that'll make this all more concrete.